intriguing video has surfaced recently, showing the wind tunnel testing of a French future fighter concept, a tailless jet fitted with prominent leading-edge vortex controllers, or LEVCONs. Interestingly, this is a central feature of the Russian Su-57 Felon advanced fighter. In fact, they look extremely similar in general configuration. This specialized control surface arrangement could see more use in the future, possibly on new generation fighter designs with tailless layouts. The original video was posted by ONIRA, or the Office National d'études et de recherches aérospatiales, France's National Aerospace Research Center. The footage in question shows a wind tunnel model prepared for the Superman project, a study conducted by ONIRA's Lille branch. The test, in ONIRA's S1 wind tunnel, was designed to study the behavior of a combat aircraft at the limits of its flight envelope. It included a new LEVCON control surface for the stealth aircraft of the future is designed to achieve 100 degrees of pitch in 1 second. The tests appear to have been carried out at the end of 2021. The Superman research project was presented at the Paris Air Show last summer and is intended to inform the development of the next generation fighter, NGF, a crewed combat aircraft that will form the centerpiece of the multinational Future Combat Air System, FCAS. Led by France and Germany, this next-generation air combat program also now includes Spain and Belgium. It's worth pointing out that, in France, FCAS is alternatively known as Système de Combat Aérien du Futur, SCAF. Furthermore, it should not be confused with the separate British-led FCAS effort, now more commonly known as the Global Combat Air Programme, GCAP, after Italy and Japan joined. Both FCAS, SCAF and GCAP include stealthy crewed combat aircraft, but also much more. Drones, air-launched weapons, and potentially other aerial platforms are also anticipated. Back to Superman, according to a report from Aviation Week last summer, the research program is focused on studying the limits of a combat aircraft's flight envelope and developing knowledge on maneuverability. Among other things, the aim is to define the shape that will enable the next-generation fighter, NGF, to be as maneuverable as possible. ONIRA describes the Superman test model as a generic form, which could be representative of the NGF. Exactly how much of the Superman combat aircraft research program will eventually make it into NGF won't be known for some time. With some, but by no means all, previous concepts showing a tailless fighter, it's clear that this is one of the options under consideration. If chosen, then it could make sense for this configuration to be combined with LEVCONs. Generally speaking, tailless combat aircraft designs confer significant advantages in terms of broadband low observability against a wide variety of radar types and reduce radar signature from multiple perspectives. Other benefits include reduced aerodynamic drag, providing better performance for sustained high-speed dashes and cruising flight. On the other hand, a tailless configuration can adversely affect overall maneuverability unless combined with advanced fly-by-wire digital flight control technology, and perhaps also thrust vectoring engine systems. LEVCONs would be another way of conferring an improved level of stability and especially agility for a tailless design like that seen in the S1 wind tunnel, without sacrificing heavily the positive attributes of a tailless design. Fitted at an airframe's wing roots, LEVCONs offer different benefits to combat aircraft at various parts of the flight envelope. For low-speed flight, LEVCONs can generate additional lift, boosting control authority, for example on approach to an aircraft carrier. It's for this reason primarily that a less pronounced version of them is found on Russia's carrier-based MiG-29K, KUB fighter and the naval variant of the Indian HAL light combat aircraft. Once deployed, they improve the aircraft's stability during the approach to the ship, but they are a much simpler proposition than the kinds of all-around flight control surfaces found on the Su-57 and the Superman study. These can work like something of a hybrid maneuvering slat and canard and even operate independently to instigate roll as part of the aircraft's integrated digital flight control system. In this kind of application, the LEVCONs serve to increase static instability, boosting maneuverability, especially at supersonic speeds. Specifically, they move the aircraft's center of pressure forward, making it more unstable and therefore more maneuverable. Managing high static instability also requires an advanced fly-by-wire flight control system. When the Su-57 first appeared in its prototype T-50 form, it was also reported that the most important function of the LEVCONs is to recover the aircraft in the event of a thrust vector control failure at post-stall angles of attack. They do this by deflecting sharply downward, reducing the planned projected area of the wing body section in front of the center of gravity.